Hello, this is John Hart, and we'll be going over the Unit 2 work ahead of us. So in this unit we'll have a discussion on these topics according to your name. And we'll also be doing, for our main act, a paired t-test in the software program PSPP. If you haven't got that going, give it a try, get it installed. If it didn't work, try again, and if not, still it doesn't install, you can use Excel. And I have a companion announcement titled PSPP. That gives directions and has videos on how to do the paired t-test. Statistical significance, which we'll abbreviate as stat-sig in the course. Is any p-value below 0.05. So this one is stat-sig, this one is not. Sometimes it's shown like this, p less than 0.05, that would be. This is an exact one. This is showing that whatever it is, it's less than 0.05, still stat-sig. This one's greater than 0.05, and if it falls right on 0.05, that would go with this, greater than or equal to not stat-sig. And the p-value tells us the probability, p stands for probability, that the difference between samples happen by chance, and statisticians generally agree that the 0.05 is the cutoff. And that's what we'll use in the course. So this is a large one, no zero there after the decimal place. This is very small, 2 zeros to the right. Cutoff, or the technical term is alpha, or another technical term, level of statistical significance. And again, anything less than that in your study results, the p-value from your study results, is stat-sig. So the variables A and B in the data you've collected from Unit 1 are the before and after weights, comparing a diet treatment, weight before, weight after. And I have help for those who have trouble installing it. Mac computers tend to have a problem with this open source program, PSPP. And this is from the PSPP announcement. For Mac users, there's a PDF file attached to either the Unit 2 announcement or the PSPP announcement. And there's a link for Mac users in that attached PDF. So if you're using Excel, make a table in your Word document reporting n number of observations or measurements. So if we have 25 students, there'd be 25 numbers, each reporting a number. 35 students, 35 numbers. The mean for A, before, and the mean after. So construct your table like that. And standard deviation in Excel, you have to do these extra calculations. PSPP does them automatically. One requirement for the t-test is that there be a reasonably normal distribution like this. And this is not too severe of a departure, the yellow behind the bell projected on top of it. And t-test is robust against moderate departures, which I think this is in the background. There are statistical tests to give an assessment of normality. It gives a more objective assessment as opposed to just looking at like these yellow bars behind. So the bars are like this line, only they're in bar form. So it'd be a little more normal if this tall one was right in the center, but it's a little off center, as you can see. So here's what your setup might look like. This is the way I set it up in mine anyway. And these three are for Unit 6 assignment. So open PSPP, and in data view, not variable view, you'll see that at the bottom. Data view, variable view. Now it's on variable view. Click on data and then paste it in. Click once and do the Control V maneuver. Right click, paste does not work in PSPP. And then click here at the bottom. Once you go through these steps, going to analyze, so just follow my video. Compare means, pair t-test with these drop downs. And once you get the variables loaded, click OK. And then it's waiting to be viewed. And here's the output. Descriptive stats. We're not doing correlation for this assignment. And here's the paired differences, paired samples test. Here's the p-value. Is that stat sig? Is it less than 0.05? Yes, it is. So the differences here, which is 3.11 between the mean 64 and 60.89, probably did not happen by chance. If you see that, that's stat sig. Just a little glitch there with that particular computer. Or maybe it's in the software at that particular time. Two-tailed means we're sig is stat sig. Two-tailed means we're open to the possibility. We're interested in whether it gets larger in the post or gets smaller in the post. In this example, it got smaller. If a research paper is using one tail, they should say so. The default in health science anyway is two-tailed, and it should say whether it's two or one. If it's one, the expectation is the researchers will explain why. One tail, it's easier to get a stat sig p-value, actually half. If two tails is 0.06, which would not be stat sig, one tail would be 0.03, which would be stat sig. So when it gets down to like 0.06, 0.08, then it makes a big difference, and an explanation is needed. If your output looks like this, there's a problem. Could be the nano. Probably because the case variable is loaded. We don't want to load that student 1, student 2, student 3. We don't need that. That's probably what did this. And Excel, got a video on how to do the paired t-test in Excel. Here's the p-value. In this example, it is stat sig, if you can see that. 0.005. Here's the example of the table. If you're using Excel, number before weight, number after weight, mean for both, standard deviation for both, p-value for difference, mean difference. Student column, before treatment, after treatment. And do a screenshot when you click on the p-value so I can see this up here, the formula. Two tails is what we use here. Just type in array 1, left click, hold it down, so just follow the video. If you see this, that's a very small p-value. That means there's 29 zeros to the right of the decimal point. 29 zeros and then 249. Very small. Is that stat sig p-value? No, it's not. And thank you for watching.